Sometimes when you're doing simulations or you have morphing geometry, you want to have your textures stay in place while the geometry continues to move or to morph. And the way that you're going to need to do that is by creating a rest UV. So I figured we'd go over how we can do that inside Houdini. So this project file will be available on Patreon, and this 3D model is available on 3dscans.com. You can grab it off of there. And all I've done is brought the file in. I've just changed the orientation of it and then dropped down a match size with it set to min and scaled to fit so it's not so massive. So I'm going to do this with grains. You can do this with RBDs or, like I said, morphing geometry, all sorts of different things it's useful for. But I'm going to do it on Vellum grains just as a demonstration. So I'm going to drop down a grain source. And if you haven't checked out my video on how to create Vellum grains, then I would definitely recommend going about doing that. But let's go ahead and take a look at this. So right off the bat, this is going to give us something that we're not really looking for. Just a few points here, so we need to drop this point separation down quite a bit. I'm going to set it to 0.015, and I'm also going to check this jitter scale, and then this should recook. There we go. And that just gives us some breakup in the position of our points here. And then we can drop down our Vellum configure grain node. And by default, this is going to be too large on the particle size, so we're going to drop that down to 0.01. And now we have a bunch of points here on in the place of our object that are more in the size that we're looking for. And then we can drop down our Vellum solver. And there's a few things that we're going to need to change in the Vellum solver. First of all, you're going to need to set these substeps up to 5. That is, or at least 5, I should say. That is the recommended if you look inside of the Houdini documentation. I'm also not really going to need constraints much here, so I'm going to drop this down to 20 just to speed things up a little bit. And in the forces here, actually, let's just press play and let's see what this gives us after we come back into our solver and check this ground position so that we have a ground plane here. So press play now. You can see that our simulation starts to play out. We have our grains falling and they're kind of shooting out all over the place, and if I zoom in here, they're kind of bouncing and everything, which we don't necessarily want. So if I come into this forces here, we can come to our static threshold. We can just set that to a value of 2, and that's going to kind of get rid of some of that spewing out. So they still bounce around a little bit, but they're not spewing out nearly as far. And if I look in here, we have some points kind of bouncing around all over the place even after the simulation is kind of played out a little bit, which we don't necessarily want. So we can get rid of that. If we come into the advanced tab, we can come into this sleeping and enable auto sleep. And what this is going to do is basically it's going to stop the grains once their velocity goes beyond, or goes slow enough, essentially. I'm going to change this threshold from 0.01 to 0.05 just so that it stops the particles a little bit quicker. And we can visualize this with a color node. If we drop this down, wire this up, this attribute is actually called the stopped. So we're going to call at stopped is equal to 1, and we'll set that to group type of points. So now if I take a look at our color and I set this to like red and I press play, you can see that some points kind of start to stop there. And then as the simulation spreads out and plays along, you can see that we have them all starting to stop. So that is kind of the gist of that. Now we can set up this animation to be more what we had in the intro animation. The way that we're going to do that is with a time warp, because I want the initial simulation here, the kind of the shape to stay in place off the start for a few frames, and then I want it to start to simulate after that. So let's go to shift range, and we'll shift the start to frame 30. And our input frame range isn't too big of a deal right now, but you can set this to a file cache if you want, and just cache out 100 frames or whatever you want to do, and you should be fine. But now if I press play with the time warp enabled here, you can see that it holds for 30 frames and then it starts to simulate and fall down, which is more in line with what we're looking for. And by this frame, they're definitely all stopped here. So we can come to a time shift, and in this time shift, we want to take this to delete channels, and we want to set this to stop after a certain number of frames. So if we were to cache this out, this is what I would do. So I'm not going to drop down a file cache. Actually, if we can just bring over this file cache from this initial simulation here. So let's bring that in, and we'll be able to, we should be able to look at what we're getting here. Let's see. So yeah, we're beyond the file cache range. So after frame 90, that's why I was getting that error. So I've simulated from frame 1 to frame 89. They're all stopped by that point in time. So I can come to this time shift here, and I can do a little expression in here so that we don't get this simulation to disappear. We can type in min and then $F and then frame 89, because that was the last frame of our simulation. So now if we go beyond frame 89 with the time shift visible, we can see that it's just that last frame right there. And the reason that, or the way this kind of works, is the min function is going to look at the current frame number, and it's going to compare the frame number to whatever frame we set, and that's frame 89 in this case. So if the frame is larger than frame 89, so if it's frame 114 or whatever, then it's going to just use whatever was on frame 89. If it's below frame 89, then it's going to use that frame. So now we can set up our rest state UVs. So with a time shift now, we can right click and delete these channels. And in this frame number, I can just set this to a frame that's stopped. We'll just use frame 89 because we know that is the frame that we stopped on. And we can drop down a UV texture node. And in this UV texture node, we can use kind of whatever projection type we want. So we can use an orthographic projection. We can set this to X, Y, Z axis, whatever we want. Y axis by default is going to shoot it kind of straight down. But just to make sure that it's working the way I want, I'm going to use a perspective from camera. And then I'm going to set up the projection cam, which if I take a look at our camera, is basically just it on the Y axis looking straight down. So let's go ahead and just rotate back around here. And we can take an attribute transfer now. We can wire in our time shift on the first input and our UV texture on the second. Take in our points, and let's go to the, let's see, we forgot to set this to a UV or a point attribute on this UV texture node, so make sure you do that. And then come to this attribute transfer and transfer that texture UV coordinates. And then I can drop down an attribute from map, and you can use whatever you want for this. I'm just going to use a render that I have made in the past, or just a still frame from that render. So we'll go to our desktop here, and we'll just use this LERP door. So I can also come into this image settings here, and I can change the scale around, and I can kind of rotate this if I want. So maybe let's go to our camera. Let's go to, oh yeah, I guess frame 126. So let's kind of align it somewhat with this, and let's crank up the scale. So if I crank up the scale too far here, you can kind of see what starts to happen. It's going to interpolate the edge of the frame all the way kind of off, and it's just going to kind of repeat that. So we don't want to go too far. Let's go to somewhere, actually that's not too bad right there. You can also translate it if you would like, move it around to get to the proper placing that you're looking for. But that is the gist of it. So if I press play now on frame 1, you see that we have this kind of a look to our object, and I've also have this camera animated. So if I press play, you see that it's going to fall down, and then after it all settles, it's going to have our texture being displayed onto these points, which is pretty cool. So that's kind of the gist of how the rest state UVs work. You can use this for all sorts of things. Like I said, you can do it for RBD simulations, grain simulations. You can use it for objects morphing and different things like that. So play around with it with different scenarios and see what you come up with. It's kind of cool workflow to work with and useful for a lot of different things. Anyways, if you want to learn more about Houdini, I have a bunch of other videos on my channel on Houdini. If you want to learn more, make sure you check those out. I also cover things on rendering, so if you want to learn more about rendering inside Houdini, then you can check that out as well. But anyways, thank you guys for watching, and have a good day.